WarsawJS.
Let's start. My name is Jerzy, and I will tell you a little bit about the optimization in web application. In the context, I would say mostly on front-end, so front-end optimization, and I'll tell you about some general rules that you should follow, and it could apply to front-end, it could apply to back-end. But mostly, since I'll be talking about our startup, ShareTheBoard, it will be on front-end. So who are we? I'm personally the head of development in ShareTheBoard, and ShareTheBoard is a web application which enables you to detect handwritten content in real time. It's mostly targeted on the whiteboards, as you can see right now. So we are trying on the simple video stream to find what is the content, what's handwritten content, what is like obstacles. We added to additional layer and present so you can, for example, work with the whiteboard on your Zoom call. So that's nice. And but why I will talk about optimization? Because a lot of stuff that we do is happening on the front end. So as you can see, we are analyzing, checking the video stream. And we need to do, and why we are doing it on the front end. The first reason is that we need the top, like the top quality video stream. So not the one which would be, for example, compressed, sent, transferred to backend. The second one, it's the things that we are doing consume a lot of the CPU, GPU, and it's just simple cost money. So we just prefer to put all the cost for the power on our users instead of doing it on the backend. As well, we are doing using a lot of interesting technology. So just mention AI. Yes, we are doing AI, but on the computer vision, so it will not try to take your job. We are using the standard classic computer vision algorithms. We are as well using the I believe, quite nice technologies like WebAssembly, WebGL, recently tried WebGPU. So to be able to run our machine learning models. I believe the biggest reason you should maybe listen to me is that we started to optimize our application from the day two almost because it was running too slow. And while trying to make it work faster, we made so many mistakes, so big mistakes in terms of like how to deal with optimization that is just, I believe, nice to learn from our mistakes. Okay, so what you should not do, I believe you should, before you start to optimize, you should think. And in our cases, when we thought, okay, our application is running too slow, let's start optimizing it. And we spent like 3 weeks fixing one of the functions that we knew that is not optimal. And we gain 10 milliseconds. Is it good? Is it bad? Like our detection time was 6 seconds, so that on the reference PC, the difference was maybe not that big, I would say. So 0.16% on the reference PC. So you should not do it. And this is quite funny stuff because it should be quite obvious, okay? You should not jump straight into optimization. But I've seen in many teams, many senior developers, great developers, who just like, okay, I see my application is running slow. Okay, I need to optimize this piece of code. Yeah, I know it's suboptimal. I know that I could do it better. And you really could do it better. But there is like the Pareto principle. And it's saying that usually the 80% of consequences comes from 20% of causes. I would say in the development world, usually your application is lagging, is running slow because of, I don't know, 1% of your code, maybe 5% of your code. Usually these are like few places, just a few places, usually written ages ago, so no one knows even how it's works. Everyone just avoid this piece of code because it's ugly. And yeah, and this is where you probably should concentrate. And it's better to gain as well 10% from 80%, for example, of the time that your application ran, then try to optimize one piece of code which is responsible for 1% of time. Because even if you manage to, I don't know, speed up 10 times, which is hard normally, then it will still be, you will speed up application by 1%. So before you start to refactor your code, before you, I don't know, move to different framework, language, change your backend architecture, anything, open the profiler. Really check what is happening, where the time is really like being consumed, where your resources are leaking. And it may be that, for example, 10 years ago, or like when the project was starting, some junior added the timeout in your main processing loop. And in fact, just removing this timeout will help you a lot. And it sounds like maybe funny, but even in our case, we had some like timeouts. There was a reason for them, but if you remove them, the whole application, it was strange, but start to run faster. Next one, I believe that you should fail. And this is also quite interesting idea, that of course it's not if you should not fail all the time, but if you are working on the bigger optimization. For example, in our case, originally we had our detection model was based on the classic computer vision algorithm. And we thought, okay, let's move to AI. Let's create our own model to detect the content in the real time. We started to do it. We gathered the data. We tuned the model. We trained it. And it was going great. On the static images, our like accuracy to detect the content was really nice. We then verified the model inside the application with the video stream. And we failed. Like it was complete disaster. It was running absolutely like just a slideshow. I'll tell you on the next slide why, but from the technical perspective, but it was. Then we've done a lot of optimization that failed. We finally decided to create our own framework to run machine learning models in JS. We tested it on the reference PC this time, and we failed one more time. And these 3 sticky notes took us like 1 year. For a small startup, it's really a lot. So unless you have, I don't know, someone who is just allow you to burn money, it's good to just fail faster. A good point in the end, we managed to like make smaller model, add some commercial model, add some classical computer vision algorithm, and it's running more or less. It's adding some additional feature, but the classical algorithm that we started from is in fact faster because we managed to optimize it in the meantime. And if you are preparing to make a bigger optimization, I'm not talking about the small one, but change framework, change your architecture, add something completely different. Start with basic POC. Check, maybe your idea is not that great. Maybe you could just scrap it on the beginning, not waste any time and resources. If it's okay, gather some data. I suggest to get the pessimistic one, so to get the upper limits of the algorithm, how fast it will be running with the real data of your solution. Mock as much as possible to make it fast, so to fail fast in any case. Only then, if it's okay, create some prototype on your, I don't know, development branch, like make the code that doesn't need to be perfect. It needs to run and prove the point if it will be better or not, because you want to check it with all the dependencies. If it's okay, then it's okay to start normal implementation. Then it will be fine. Next thing that is you should avoid like concentrating on single KPI. And in our cases, we are measuring, I mentioned it before, the content detection time. So to make it as fast as possible so the people could like use the whiteboard as they use normally. So we, as you know, neural networks usually run quite fast on GPU. So we managed to achieve quite nice detection time. But we completely blocked the GPU. So we managed to make our user interface completely unusable. It was like a slideshow. So why it was, like this is a little bit of technical stuff which you may find interesting, is that TensorFlow, while using the WebGL, is giving the whole job. So in this case, we are trying to we'll calculate the inference from the model, so to get results from our trained model. And it was queuing so many operations on the GPU that it was blocking the user interface. In case of desktop application, you can use some function to just finish part of the calculation. But in case of WebGL, you don't have this option. In case of TensorFlow.js, you don't have this option. So we, in the end, created our own framework, which enabled us to get our whole network. We splitted all the operations into the smaller batches. And after each of them, the implementation was in GLSL, so in shader language, so in shaders in general, shader applications. And we calculated the smaller batches and then forced to finish the calculations by calling the read pixels. And then the user interface thread could go into and render itself. And we managed to receive the results in which the user interface was usable. Another big thing that you can make is only using top hardware for your optimization work. So for example, you are preparing new algorithm, new solution, new feature, anything, and then you are saying, okay, it's running with this speed, I'm trying to optimize it. For example, I managed to decrease the time spent on the algorithm by 10%, which seems nice. And we've done it while moving from WebGL to WebGPU. WebGPU is a new API which allows the TensorFlow to access the GPU directly without the WebGL. So it should be better, and it was better. But then we started to test it. By accident, we noticed that in case of the PCs with the Intel CPU with dedicated graphic card, it was having negative effect on the solution. So it was running slower. So it's quite important to know that if you see you have gaming PC calculator and Office PC, they are different. You know it, they have different computational power. But when you are trying to optimize on the client side, you need to remember that they can run differently. So for example, there could be difference in the CPU. On the Intel, you will have, I don't know, you will manage to improve the speed by 10%. On the ARM, so on the Mac, it will be 20%. But for example, on the Intel with old integrated card, it will be, the speed will be slower. Even the types of GPU, it could be when running, for example, ML, the old integrated GPUs versus the new, like Iris. Iris is faster. As well, for example, user could use older Safari version. The new one finally support the off-screen canvas with the WebGL. So you can use on the new Safari with TensorFlow JS with engine, which is using the GPU. But in older version, you were forced to use the CPU and then using the engine with WebAssembly or native JS, like WebAssembly usually faster. And the last point, which I wanted to mention, is about fear the reaper. So you should not fear it. Normally people are. So we are creating new features. We are creating, I don't know, new architecture, adding stuff. And it's something, okay, we've made it. It's nice. It's shining. We should not remove it. And sometimes the best way to optimize a feature is to delete it. Because if you delete it, it doesn't run, it doesn't consume any CPU or RAM or anything. And in our case, we put a lot of effort into the content vectorization. So we detect the content, so we have the pixels, and we vectorize them so they will look nice. For example, this Reaper is taken from the application itself. So I wrote something on the board and use our startup, take out of it the image, and I could place it as an icon. So it was quite nice. The view was really nice. And we hope it will optimize the transfer as well. So we'll manage to reduce the data because everything that we detect, vectorize, we are sending to our servers. So the idea was but in the end, the amount of data that we're sending to the server was bigger. So it's kind of tricky with SVG. If it's simple, it takes less data than for example, bitmap, but some compressed bitmap, I don't know, PNG image. But if you have very complex, I would say, curves, and for example, the handwriting is taking more space. So it was maybe in the beginning, the idea was that it would be nice, but in reality, it was not so nice. So we decided to simply remove it. We just keep it in the few places which are not critical in terms of performance, but just remove it. Another one, we use, this is also maybe not deleting a feature, but making it much simpler, easier to calculate. And in our case, we use for the classical vision algorithm, use median filter, which was taking a lot to compute. And we just make approximation. So in the result, the effect was worse, so we decrease the accuracy, but make it much faster. And as well, you can just ignore some stuff. So for example, the Safari, older Safari cannot handle off-screen canvas. So be it, we'll just ignore it. So we keep our original implementation behind some ethology, so it will run OK for in Safari. But in the old optimization work was focused on the newer web browsers like Chrome, because, OK, we checked that it was 1% of our users were using old Safari. So, OK, let them use old Safari. So this is what I think it's nice to check. It's the tech area, but as well stuff related with the business stuff. And I notice in my experience that usually the business side likes to add features, don't like to delete them, and you can sometimes you cannot. Sometimes you will point them, OK, no one is using your feature, no one. For last year, but still, yeah, let's keep it because it's so nice. But sometimes they will agree, OK, we can delete this, and it will make your application faster and easier to maintain, so it's good to delete unused stuff. And in the end, like I would say that why a little bit about the front end. So it's changing. It's like in the past, probably a few years ago, I will not make this kind of presentation because on the client side, I don't know, you made application which was interfaced to the backend, and it was fine. But right now, you have more and more like image processing, video processing. You can have machine learning algorithms, which you might like or not like, but usually business like them, so they want to check them as well, for sure. You want to have advanced algorithms. You can have games. You have quite a new tools. So you have WebAssembly. So for example, this was about breaking the silos that we use a lot of C++ code in our application because originally it was the desktop application. And we decided, OK, we have the WebAssembly. We could pack up the C++ code, and then we can run in on the web browser and move from desktop application into the web application. So it's like also, like I would say, breaking these silos. Mentioned before, you have new machine learning technologies like TensorFlow, GS, WebGL. Right now, like this Web GPU that I've mentioned during the presentation, it's something which has been released just like 2 months ago, and we already been testing it. But one thing, with the great power comes great responsibility. So when you are making this application, you are adding a lot of these fancy algorithms. It may just run slow. It may run slow on your user machines, and it's good to just think about it and not to make the same mistakes as we've done in the past. Yep, so thank you.
That's it?
Yeah, that's it. I believe 20-something minutes.
No, I think amazing. OK, we have our first question here, right in front. Here you go, sir.
Thank you. I'm interested in how your startup is doing from a business perspective. Do you have customers? If you do, how many of them? And
oh my God, it's supposed to be no aggressive questions at on the presentation.
I'm just curious about that because, like,
that's the answer?
No, the answer is that, in fact, we are trying to make the customers. We are right now signing the first contact with the big enterprise. But I would say it's not very difficult. It's not very easy. The most difficult part is that this is quite a new concept. So it's very difficult to present it to the customer that customers like something, oh, I'm making the new Uber, but I don't know, for trees. And they think, whoa, Uber for trees, that's great. And they already like it. But in this case, if I would not show you the video, usually to describe the concept, it's not that easy. So we are like, this about selling the product. We are building, in fact, the market, a lot of to bringing knowledge to the customer. And as well, one tricky part is that if we want to sell it, we need to first demonstrate the solution. Because it's like for people, if they trying our application, they treat it as a mirror. And they should not. They should just like open the camera and work with normal whiteboard. So it's like, I would say, moderate. So we right now finished our budgeting from European Union, which was helping a lot, which I'll make in a second a selfie of myself, so I'll have the proof that we are propagating our ideas. But right now we don't have it, and we still manage to keep the startup. So it's not unicorn. We hope we'll be.
Thank you.
Mm-hmm.
answer. I love that. People are always looking for proven success. Show me that it works. Next question.
May I? Just a quick question. I have another question similar to the previous one. I would like to integrate your solution in my tools. Are you ready to grant me access?
Yeah, this is, if you'd like for big partnership, then yes. Normally we thought about providing the API for our engines. Yeah, but the issue is with the video quality. So this is something why we are doing so much on the front side, is that if we transfer the data, transfer the video stream to the server, then it gets compressed. Then it gets some compression artifacts. And then we'll start recognizing these artifacts as a content. Because this is quite tricky that when you are seeing the content written on marker by the whiteboard, it's like for you, your brain recognizes it. But really, from the perspective of the image, it's very close to, for example, shadows, very close to, for example, some glares. And if you add the compression, then so. And as well, it will cost a lot. So this is one idea which we were recently discussing, but we decided that probably not. So if you are building your solution, we could sell you the engine, so you can embed the engine into your solution on the front end. But as a back end, probably not right now.
Okay, thank you.
Hold on a second. One moment. We need to get your question on mic because we have an online audience who are watching live.
Okay, so my question is, how are you transferring the data to the backend and to other users? So, for example, are you using WebRTC or WebSockets?
We are using WebSockets. We are transferring to our backend. We are using the Redis to fan out the messages to other users as a hub to fan out to handle the messages. In fact, it's quite nice because Redis has some subscription plan. We are using Redis Cloud, and we are paying like $6 per month to have the Redis, which is able to handle all of our traffic, and then it's going to the users by the WebSockets. But it's this is also quite complex question because one thing is how we send the data. So because we have two streams. One is the video that you've seen. So the video with the user and all the content on him, so on video stream with it. And we have the stream of the content itself. So only digitized content taken from the table. So it's like whiteboard and something that you have written on the board. And we transferring this content, digital content, so we also store it on the backend. We can save it, we can analyze it and do something with it. But the video stream, at the beginning, we thought that, okay, we will transfer all the video, the content and the video together. But it was just expensive. To be Zoom, to be, MS Teams, you need to have a ton of your own servers to make it to make a good business use case. If you are using public cloud providers, this kind of video communicator will be expensive. So we are using, in fact, to transfer the data, we use the MS Teams, Zoom, and other applications. And these are two approaches that we have. One that you could simply share the screen, and the second one, we are as well developing the content camera, which is like our web version embedded into the Electron. And then we produce the video stream from you can use our virtual camera, which have all the stream and all the content on it. And then you use this, our virtual camera, inside the Zoom. So then the transfer of the heavy data, so video stream, is not on us. We don't need to pay anything for it. And as well, it's good for user because no one will switch the communicator to use our solution. They may use it as an add-on, not like a core communicator. We don't make communicators.
Artur, I liked your question about collaboration. You didn't see that as an aggressive question? Hey, can we cooperate? Yeah.
No, it's good. If they're bringing money, it's good. We like money.
Very important point. Yes, one more question.
I'm just curious, how do you see your company in the future with the advancement of AR technology?
Yeah,
Excuse me.
No. It's a very good question because, yeah, there is, but one thing, if you, for example, one of the use cases for the education of our solution is not in fact remote collaboration, but like semi-remote, is that if we have our like whole, we will having class in this room, it's someone from there are some, I would say, scientific badania, research saying that people who are in the class on the row 4th or 5th, 6th, 7th, 8th, 9th, 10th are just not listening. Their concentration drop rapidly. So for example, from university perspective, it's that we have all the people in the class and they are like checking what is written on the table on their smartphones. And in this case, you, of course, could have the whole class of people with the AR glasses, but it's like, I don't see anyone with AR glasses in here. So maybe presenter could have maybe one person, but you need to have a big investment. You need to provide these AR glasses. And I can tell you that when, for example, American universities are buying equipment, to buy cameras for them is taking 1 year. So no, buying AR glasses, we have still time before they buy.
Phew, I like the idea that we still have time.
Yeah.
That's a huge relief. It's possible that we have time for one more question. And here it is. You ready, Sarah?
Yeah. Okay. Did you think about reverse engineering? Because you made a big progress and you left all calculation on client side. Are you afraid that somebody will steal your code, your algorithms?
Come on, no. It will be easier for them to buy us than to reverse engineer the solution. Bravo. Yeah, it's just like, of course they could, but it will take them so much time. It's easier to just bring the money, and we'll probably sell for this kind of money. So no, we are not.
Okay, thanks.
Mm-hmm. Okay.